Yes, good morning, all of you. Let me conclude the complete mechanical system in this class. As usual, just give me a minute of time. What happened in the previous classes? All of you aware, I'm coming from this slide just at a glance. That's no, I'm not going in depth, just within less than 60 seconds, just closing this matter. So in the previous three classes, I started the mechanical system. So and based upon the motion, it is classified into translational and rotational systems. It is clear. Okay. Then briefly I explain about the mechanical translational systems and also the mechanical rotational systems. This in point of view theory. After that, I have clearly given you the elements of mechanical translational systems are M, B, K, and the variables are force and K. And in the force and displacement X. And in the same way for rotational system, the elements are J, B, K, and the variables are torque T and angular displacement theta, what we have discussed in detail. And now further, the mathematical relationship between the force F and the output variable X for mass M, and then B, K I have given in detail for both mechanical translational and rotational system. Now after that, in the previous week, we solved how to find out the transfer function of mechanical translational system by using these 5 steps of procedure. And in the same way, in the previous class, you have solved how to obtain the transfer function of mechanical rotational system by following the same procedure, 5 steps of procedure. That is in which you have assumed each node as each displacement as a single node, and then the elements which are connected to that particular node, you have extracted from that one. You have drawn the free body diagram, and then after that, applying writing the equations, applying Laplace transformation, you have been calculated or obtained the ratio of what final output by input, what he has asked in the question. Now next today's fresh topic, I can say this is an extra topic. Already concluded how to all of you from the knowledge of previous classes, starting from my 5th class to previous yesterday's class, totally 7 from the knowledge. Only single concept I am discussing, that is transfer function. So in the first 4 classes, you came to know how to find out the transfer function of an electrical system. After that, from the last week to till last class, 3 classes, you have learned how to obtain the transfer function of mechanical system by following the previous procedure what mentioned in this particular slide. Now today, in addition to that particular one, to conclude this final mechanical systems, an additional topic is there. Actually in your syllabus book it is not there, but in few question papers, maybe he is asking you to find out the transfer function of mechanical system, he will be asking you the write the electrical analogous system of the given mechanical system. So what is an electrical analogous of given mechanical system? Just I will explain you first, then directly we will jump to problems. As all of you aware that from the 5th class to till the end of the semester, I told you all the things are what problematic topics. Hence, now first of all, what is an analogous system? Analogous, what is the actual meaning of analogous system is, I can say analogous means equivalent. So what is this topic means? You are going to convert the given mechanical system into electrical equivalent system. In other words, I can say that you are going to convert the mechanical circuit into an electrical circuit. That's it. How your mechanical circuit looks means he will be giving in the problem. All of you aware the mechanical circuit consists of the elements M, B, K and the variables force and displacement X. In the same way, what are the variables and elements? How your electrical circuit looks means all of you are learning from first year that the electrical circuit consists of the elements R, L and C and the variables of voltage and current. Now here in this particular topic, today's class, to conclude this mechanical system, you are going to learn how to convert the given mechanical system into an electrical circuit. Now what is first, before going to explain you how to convert, what is the need of converting the mechanical system into electrical system means that this is not important. I can say that the electrical analogy means electrical circuit is of any other kind of system is of having great importance. Why I am saying this is most important means, so see here, being you EEE students or electrical students, it is very easy to analyze, to solve that electrical circuit rather than comparing to any other kind of system. For example, mechanical system. మీకు ఒక మెకానికల్ సిస్టమ్, ఒక సర్క్యూట్, మెకానికల్ సర్క్యూట్ ఇచ్చేసి యూ ఫైండ్ అవుట్ ద మ్యాథమెటికల్ వాల్యూస్ ఆఫ్ ఫోర్స్, మ్యాథమెటికల్ వాల్యూస్ ఆఫ్ డిస్ప్లేస్మెంట్ ఎక్స్, మ్యాథమెటికల్ వాల్యూస్ ఆఫ్ ఎం, బీకే ఆర్ ఫైండ్ అవుట్ చేయాలంటే యూ విల్ ఫీల్ లిటిల్ బిట్ కాంప్లెక్స్. సపోజ్ ఫర్ ఎగ్జాంపుల్ ఆయన ఎలక్ట్రికల్ సర్క్యూట్ యూ హ్యావ్ గివెన్ సిరీస్ ఆర్ఎల్సి సర్క్యూట్ ఇచ్చినాడు, ఇచ్చి ఫైండ్ ద కరెంట్ ఫ్లోయింగ్ ఇన్ దట్ పర్టికులర్ సర్క్యూట్ అంటే సింప్లీ బై అప్లైయింగ్ KVL, writing the R equivalent, and then you can able to find out within less than a minute. Why means it is very easy to analyze an electrical circuit, analyze and solve. Solve అంటే ఏమి, దాంట్లో ఉన్న పోతున్న కరెంట్, దాంట్లో ఉన్న ఆల్ వాల్యూస్, వోల్టేజ్ డ్రాప్స్, కరెంట్ ఆర్ ఎలిమెంట్ వాల్యూస్ ఎక్సెట్రా, ఎవ్రీథింగ్ షుడ్ బి నోన్. దట్ ఈస్ నోన్ యాజ్ వాట్ సొల్యూషన్ ఆఫ్ దట్ పర్టికులర్ సర్క్యూట్. సో ఆ సొల్యూషన్ అనేది మీరు ఈజీగా చేయొచ్చు, ఎందుకంటే కంపేరింగ్ టు ఎనీ అదర్ కైండ్ ఆఫ్ సిస్టమ్, ఐదర్ ఇట్ మే మెకానికల్ సిస్టమ్ or either it may be electronic system or either it may be chemical systems etc. Why I am saying this electrical circuit analysis is very easy means there are different methods to solve an electrical circuit. One is KVL, another one is KCL, or else you can go for mesh analysis, you can go for nodal analysis, other else you can go for super mesh analysis, or else you can go for super nodal analysis. Now in the same way, even though you can use what network topology to solve the circuit. సో అంటే నేను చెప్పాల్సింది ఏమంటే దెర్ ఆర్ డిఫరెంట్ వేస్ టు సాల్వ్ ఎ పర్టికులర్ ఎలక్ట్రికల్ సర్క్యూట్ కంపేరింగ్ టు ఎనీ అదర్ కైండ్ ఆఫ్ అదర్ సిస్టమ్స్. ఇంకా సింప్లెస్ట్ లాంగ్వేజ్లో చెప్పాలంటే, సపోజ్ ఫర్ ఎగ్జాంపుల్, సపోజ్ పబ్లిక్ స్పీకింగ్ ఉంది అనుకో. సపోజ్ మోడీ వచ్చినాడు కర్నూలుకి మోడీ గారు వచ్చినారు, ప్రైమ్ మినిస్టర్ ఆఫ్ ఇండియా. సో మోడీ వచ్చి he does not know Telugu, but the peoples of Kurnool knows only Telugu. రూరల్ ఏరియాస్ కి కన్సిడర్ చేసి అన్ని పీపుల్స్ గ్యాదర్ అయితే జనరల్ లాంగ్వేజ్ ఎవ్రీబడి నోస్ ఈస్ తెలుగు హియర్. కానీ మోడీకి తెలుగు రాదు. ఆయన తెలుగు రాదు కాబట్టి నా ఇక్కడ మనకు సపోజ్ నేను క్లాస్ కూడా ఆయన కానీ వాట్ ఎవర్ ఇట్ మేబీ నేను తెలుగులో చెప్తే చాలా మందికి ఈజీగా అర్థమవుతుంది. మదర్ టంగ్ లో చెప్తే చాలా మందికి ఈజీగా వెంటనే మైండ్ యాక్సెప్ట్ చేసేస్తుంది, కంపేరింగ్ రాదర్ దాన్ టేకింగ్ ఎనీ అదర్ లాంగ్వేజ్. ఇన్ ద సేమ్ వే సో మోడీ తెలుగు మాట్లాడలేడు, ఆర్ ఒకవేళ వచ్చినా అంత సరిగా రాదు, ఆర్ రాదు అనుకోండి, హిందీ వస్తుంది అనుకోండి, మోడీకి హిందీ వస్తుంది, హిందీలో స్పీచ్ ఇస్తున్నాడు, కానీ ఇక్కడ పబ్లిక్కి హిందీ రాదు, ఆర్ ఇంగ్లీష్లో స్పీచ్ ఇస్తున్నారు, పబ్లిక్కి రాదు, ఓన్లీ తెలుగు రావాలా. అప్పుడు ఏం చేస్తారు, మధ్యలో ఒక మీడియేటర్ పెడతారు. వాట్ ఈస్ ద వర్క్ ఆఫ్ మీడియేటర్? ఈస్ గోయింగ్ టు ట్రాన్స్లేట్ వాట్ ఎవర్ ఇట్ మే బి ద స్పీకింగ్ బై ద మోడీ. ఒక 5 minutes 5 sentences తర్వాత ఆగిపోయిన తర్వాత మళ్ళీ ఈ మధ్యలో ట్రాన్స్లేటర్ ఉంటాడు కదా పబ్లిక్ స్పీకింగ్ లో, ఆయన తెలుగులో మళ్ళీ ట్రాన్స్లేట్ చేసి ఎక్స్ప్లెయిన్ చేస్తారు పబ్లిక్. సో మీడియేటర్, వాట్ ఈస్ ద డ్యూటీ ఆఫ్ మీడియేటర్? హీ ఈస్ గోయింగ్ టు కన్వర్ట్ ఇన్ టు ద రిక్వైర్డ్ ఫార్మ్ విచ్ ఈస్ వెరీ ఈజీ టు అండర్స్టాండబుల్ ఫర్ ద పబ్లిక్. సో దట్ ఈస్ ద Telugu language. Here also in the same thing, what in this class you are going to do here is, for the given mechanical system we can able to convert the given mechanical circuit into an equivalent electrical circuit. How to convert we will see here in this particular class. ఎందుకు కన్వర్ట్ చేస్తున్నాం అంటే అడ్వాంటేజ్ ఇదే, ఒకటే లైన్ నోట్ ఇక్కడ ఇచ్చినాను కదా, టేక్ ద స్క్రీన్ షాట్ ఆఫ్ దిస్ స్లైడ్. ఇక్కడ ఏమి ఇచ్చిన నోట్, ఎనీ అదర్ కైండ్ ఆఫ్ సిస్టమ్ కన్నా ఈ ఎలక్ట్రికల్ సర్క్యూట్స్ వెరీ ఈజీ టు సాల్వ్. ఎందుకు సాల్వ్ అంటే నేను చెప్తున్నాను కదా, ఓమ్స్ లా ఉంది, KVL ఉంది, KCL ఉంది, మెష్ అనాలిసిస్, నోడల్ అనాలిసిస్, క్రామర్స్ రూల్స్, సూపర్ మెష్, సూపర్ నోడ్ ఆర్ నెట్వర్క్ టోపాలజీ, ఇట్లా నంబర్ ఆఫ్ టెక్నిక్స్ ఆర్ దేర్. ఫ్యూచర్లో ఇంకా చాలా వస్తాయి బేస్డ్ అపాన్ సబ్జెక్ట్. సో ఎలక్ట్రికల్ సర్క్యూట్ అనేది చాలా ఈజీగా అర్థం చేసుకోగలుగుతాం. ఫైనల్ కన్క్లూజన్ ఆఫ్ దిస్ స్లైడ్ ఈస్, ఎలక్ట్రికల్ సర్క్యూట్ అనేది చాలా ఈజీగా మనము అర్థం చేసుకోగలుగుతాం కంపేరింగ్ టు ఎనీ అదర్ కైండ్ ఆఫ్ అదర్ సర్క్యూట్స్. హెన్స్ ఏదైనా సర్క్యూట్ మనకు అదర్ సిస్టమ్ నుంచి ఎలక్ట్రికల్ గా కన్వర్ట్ చేస్తే అందరికీ ఉపయోగం, చాలా ఈజీగా అనలైజ్ చేయడానికి పనికి వస్తుందని అర్థం. అది మ్యాటర్. ఈ అనలైజ్ అంటే ఏమి, దాంట్లో ఫ్లో అవుతున్న కరెంట్ వేరియబుల్స్ గురించి వాల్యూ ఇన్ఫర్మేషన్ అనేది చాలా ఈజీగా క్యాలిక్యులేట్ చేయొచ్చు. Now based upon electrical circuit there are two types. One is based upon your electrical and mechanical system, there are two types of analogous system. One is here, if you observe, force to voltage analogy. First type is force to voltage. Force ante emi mechanical translator system to voltage. Voltage ante converting the mechanical translational system into an electrical circuit with a source as a voltage source. All of you are aware that a circuit can be designed by voltage source or current source. Now here I am considering what a voltage as the source. Now, or else the same mechanical system you can convert into what if you are using current source, then that is known as what force to current analogy. In the same way, if you are having, all of you are aware that one more mechanical system is there, that is rotational system. Akkada rotational system lo variables is what torque T. So if you are, can able to convert the torque into voltage, then that is known as a torque to voltage analogy. Or else if you are using current source, then that it can be known as what torque to current analogy. Now next is I am going with this one. So all of you are aware that now in this class, whatever it may be you are going to learn, everything is known to you. Just I am moving away and then directly I will jump to the problem. How I am going to convert the given mechanical system into electrical circuit ante all of you, if you consider translator system, B, M, K anedi elements, F and X is the variables. So to write the mathematical expression, how you can write the force applied force F is equal to M into d square x by dt square for M, for B plus B into dx by dt plus K into X according to force balance equation. That is Newton's law. Action is equal to reaction. If applied is equal to opposing force. The same thing I have written. That is equation 1 consider cheyandi. Other rotational system lo same thing but symbols maripotayi. So T anedi ayipotadi force badalu J into d square theta by dt square plus B into d theta by dt plus K into theta. Now in the same way, for if you all of you are aware this electrical circuit known starting from your first year, that is if an voltage is applied to the three elements RLC, then opposing voltage drops will be there, VR, VL and VC. So if you write the mathematical expression for this one by applying KVL, then V is equal to what is the voltage across L? L into di by dt plus I into R plus 1 by C into integration of I dt. Now if you observe this equation, this is the first order equation and this is the second order equation. To compare this mechanical system with the electrical circuit, we know that all of you, the current I is equal to dq by dt, that is charge by time. So if just simply I am replacing the current in the form of charge, then I can write V is equal to L into, as one differentiation is already there with this one, d square q by dt square plus R into I place lo dq by dt plus 1 by C into integration, differentiation are going to get cancelled. Then you will get what Q. So if you compare these three equations, you will get the equivalent of force is under here torque and here what voltage. So I can say that the equivalence of force and torque is voltage. The equivalent of mass is what inductance L, and the equivalent of B is resistance R, and the equivalence of K is what 1 by C. And in the same way, the equivalent of displacement X is here the charge. Adi. And all of you are aware that dq by dt is equal to I kavati. So I can write that the equivalent of I is, I can write the dx by dt. What is dx by dt? Once again, it is velocity. The same thing I have representing in the form of table. The same thing in the mundu chepnede. So force is equal to voltage, mass is equal to inductance, B is equal to R, and spring K is equal to elastance, that is 1 by C, and the displacement X is equal to charge Q, and the velocity V is equal to what? The current I. This is related to force to current voltage source, force to voltage or torque to voltage, and converting the given mechanical system with a voltage source. Now in the same way, suppose if you want to convert the given mechanical system into current sources, I am considering the same slide. Now you know I have replaced the voltage source to current source I. Then if you by seeing these three elements RLC, now if you can able to write an equivalent equation, then you will get I is equal to C into dV by dt plus I, the current flowing through I is equal to, you can write the voltage, let the voltage across each element is V, and V by R plus 1 by L into integration of V dt. All of you aware this is first order and this is second order. So to convert that into second order, I can write the expression mathematically. The voltage is also equal to what? The voltage is also equal to the flux per time. That is, you can write d phi by dt. Here, this is phi is what? Flux. If you replace this one, then here this will become C into d square phi by dt square plus 1 by R into d phi by dt plus 1 by L. Here integration will B gets cancelled. Now if you come to questions, now this time you are going to get the force will be equal to what? The current I. The force is equal to the current I, and the mass this time is equal to what? Capacitance C. And similarly the spring K is equal to 1 by L. Okay, and the damper element B is equal to 1 by R, that is conductance. And now next the displacement X is equal to, now this time flux. Previously this was charge, now this time flux. You can take the screenshot of this table. And now here the velocity V is equal to what? The voltage. In this particular, the velocity is equal to what? Voltage. You take the screenshot of this force current analogy, and also you take the screenshot of this force voltage analogy. Here is the end of this introduction. So final conclusion is, you can able to convert the given mechanical system, either it may be translator system or rotational system, into an electrical system in two cases, in two ways. One is with voltage source and another one is with the current source. Either way we can follow the same thing. Now next is, now mathematically I have just compared these things, and I can able to convert the given mechanical system into what? Electrical circuit. Now rather than going with imagination, let me solve the first problem. So here you will be getting in the examination the question like this. Now in this particular additional topic, you are not going to find out the transfer function. Remember that one. So transfer function is different concept. Now here you are not going to find out. Now here he has asked you write the differential equations, and now draw the force voltage and force current analogous electrical circuit. అంటే మీకు ఏం అడుగుతున్నాను అంటే ఇక్కడ టూ క్వశ్చన్స్ ఉన్నాయి ఒకే దాంట్లో. ఒకటి ఏం అడుగుతున్నాడు, రైట్ ద కన్వర్ట్ దిస్ గివెన్ మెకానికల్ సిస్టమ్ ఇంటూ ఈక్వివలెంట్ ఎలక్ట్రికల్ సర్క్యూట్ విత్ వోల్టేజ్ సోర్స్ ఒకసారి, తర్వాత విత్ కరెంట్ సోర్స్ ఇంకోసారి. ఈ రెండింటికి మనం కన్వర్ట్ చేస్తాం ఇన్ దిస్ పర్టికులర్ ప్రాబ్లమ్. అండ్ నౌ రిమెంబర్ ఆల్ ఆఫ్ యూ దట్ in the previous class లో చెప్పిన ప్రాబ్లమ్స్ maximum అవే అడుగుతారు. ఒకవేళ he is not concentrating on you to ask the determination of transfer function, then he will be asking an alternate method. కొన్నిసార్లు previous question papers లో అడిగినారు కాబట్టి I am going with this particular one. Now let me solve as a first as this is the first problem. Let me solve this first problem here. So if you observe this one, all of you are aware that here how many displacements are there? How many displacements are there? There are two displacements. One is x1 and another one is x2. So what are the elements which are connected to x1? So if you observe this one, the first step to write the differential equation, you need to follow the first step. What is the first step? Here you have to write the variables related to displacement. The elements related to displacement x1. What are the elements related to displacement x1? One is mass m1. Observe చేస్తే ఇంకోటి ఫోర్స్ ఎఫ్ అండ్ ఇంకోటి b1. as b1 is directly connected to ground కాబట్టి you can write like this. One element is force, another one element is m1 and another element is b1 related to x1. What are the elements which are related to x2? If you observe చూస్తే m2 అనేది you can consider for this one, and k2 is connected, and also what? b2. Next is any further elements are there. There are two elements x1 and b12 which are చూస్తేనే చెప్పొచ్చు x1 x2 కి మధ్య ఉన్నాయి కాబట్టి you need to consider this x1 and x2 are the common elements. So common అంటే x1 కి x2 కి మధ్య ఉన్న two elements are what? One is k1 and another one is b12. Now ఇక్కడ అబ్జర్వ్ చేస్తే ఇక్కడ నుంచి x1 స్టార్ట్ అవుతుంది, ఇక్కడ x2 స్టార్ట్ అవుతుంది. అబ్జర్వ్ చేస్తే వాట్ ఆర్ ద కామన్ ఎలిమెంట్స్ ఏమేమి వస్తాయమ్మా? k1 b12 and then m1. కానీ నేను చెప్పిన నంబర్ ఆఫ్ టైమ్స్ రిపీట్ చేస్తున్నానమ్మా, m1 కెనాట్ బి కన్సిడర్ యాజ్ ఏ కామన్ ఎలిమెంట్. ఎందుకంటే మాస్ ప్యూర్లీ మాస్ ఎలిమెంట్ ఒకే డైరెక్షన్ లో ఉంటుంది డిస్ప్లేస్మెంట్, నాట్ ద బోత్ డైరెక్షన్. బట్ ఈ స్ప్రింగ్ ఆర్ దిస్ ఎలిమెంట్ కన్సిడర్ చేస్తే టూ డైరెక్షన్ లో డిస్ప్లేస్మెంట్ ఉంటుంది. ఇట్ జస్ట్ లైక్ అన్ ఎలక్ట్రికల్ సర్క్యూట్ హ్యావింగ్ లైక్ దిస్. ఓకే, an electrical circuit having like this element, common element. దీంట్లో కరెంట్ I1, దీంట్లో కరెంట్ ఫ్లో అయితే the resultant current will be the displacement of these two currents. ఆ విధంగా మనం కన్సిడర్ చేస్తాం. Now once if you extract as a ప్రాబ్లం చేసేటప్పుడు ఫస్ట్ స్టెప్ ఇస్ ఎన్ని డిస్ప్లేస్మెంట్స్ ఉన్నాయని అబ్జర్వ్ చేస్తాం. అబ్జర్వ్ చేసిన తర్వాత ప్రతి డిస్ప్లేస్మెంట్ కి ఏమేమి ఎలిమెంట్స్ కనెక్ట్ ఉన్నాయనేది మనం అబ్జర్వ్ చేస్తాం. అబ్జర్వ్ చేసిన తర్వాత once if you observe the number of display elements connected to that particular one, then draw the free body diagram. Now I am going to draw the free body diagram. here. Let me delete this one. Now, so solution for the first problem is, solution for my first problem is, so here in the given problem previously it has given one node. There are two nodes x1 and x2. Just I am noting those one. What are the elements which are related to x1? So he has given what one element is force F. I have remembered the diagram, since directly I am going to draw. Another element is what, m1. Okay, and next another element is v1. V1. There are three elements which are connected to this one. So B1. Now next is there are three elements related to x2 alone. One is m2. Another one is V2. One more element is there, that is what, K. Just parallel ga rayala ekkadaina raskochu. That is K2. And the common element here are two elements కాబట్టి I am just drawing in parallel. This is the common element what I am going to draw. So this is K1 and this is B1, 2. Now, so this is your second step, first step, drawing the free body diagram. Okay, now next is writing the equation. So now I am writing the first equation at x1 node. What is the equation here? At the x1 node, what are the applied energy here? Force is the applied, LHS. You will get force F. What are the elements connected to x1? Four elements are there. 4 ki sum rastam. One is m1 into d square x1 by dt square plus another one is b1 dx1 by dt plus another one is b12. Now as it is also connected to x2 kabatti you need to write dx1 by d2 minus dx2 by dt, and another element is plus k1 into x1 minus x2. Next, second equation is at x2 node. What you will get, left hand side 0 is equal to, as there is no energy. How many elements connected? There are 5 elements here connected. So one element is m2 into d square x2 by dt square plus another element is b2 dx2 by dt plus another element is k2 into x2 plus one element is b12 into, now this time this is dx2 by dt minus dx1 by dt plus and one common element. Now this time it is what, writing with respect to x2 kabatti x2. So this is your equation 1 and this is your equation 2. There is your second step. Now going for the third step. Now I am going with the third step. Now to write the third step, just before next, now as we are not solving any transfer function, hence you have to go for what? Hence you had there is no need to go for what? Determining the applying the Laplace transformation. నేను ఈ ఈక్వేషన్స్ ని నేను ఈక్వివలెంట్ గా ఎలక్ట్రికల్ ఈక్వేషన్ గా కన్వర్ట్ చేస్తాను. సో బిఫోర్ గోయింగ్ ఫర్ కన్వర్షన్, ఆల్ ఆఫ్ యూ అవేర్ దట్ what is the equivalent of displacement x? Now if you observe the display equivalent of x ki equivalent is charge. But in general మనం electrical circuit equations అనేది current కి రాస్తాం. Current కి రాసినప్పుడు what you can write here, x can be written as, what is current? I is equal to dq by dt. Hence I can write this one as dx by dt, or I can write the expression as dx by dt is also equal to what? Velocity. Velocity lo unte equation directly I can write the expression in terms of what? Current I. So ఏం లేదమ్మా, ఇక్కడ x లో ఉంటే నేను ఏం రాయాలా? d square q by dt square రాయాలా. ఒకవేళ అదే displacement velocity లో ఉంటే ఏమి డైరెక్ట్లీ I can write I by di by dt like this. So So hence, before going for writing the next equations, I can write here as d square x by dt square is equal to dv by dt, velocity. And next I can write what I can do here, one more equation. I can write dx by dt is equal to velocity v. And further I can write integration of x dt. Sorry, x is equal to x మాత్రమే ఉంది కాబట్టి, so x can be written as, if x dx by dt is v, then x will be equal to integration of v dt. So on replacing these things, then I am getting the new equation, that is equation 3 and 4. Let me write equation 3 and 4. So I can write the once again equation 1 as, equation 1 implies force F is equal to, I can write m1 into, in the place of dx square I can write dv1 by dt, here v ante velocity, plus ingo equation b1 into v1 directly, plus ingo equation b1 to v1 minus v2, plus ingo equation k1, expression k1 ki integration of, you can write integration k1 into integration of v1 minus v2 into dt. This is your equation 3. And further equation 2 implies on replacing, on replacing x by velocity, 0 is equal to, you can get m2 into dv2 by dt plus b2 into v2 plus integration, sorry, k2 into integration of v2 dt plus b12 into integration of v2 minus v1 plus k1 into integration of v2 minus v1 into dt. This is your equation 4. Now next, in the problem, the first part is, he has asked us, you need to convert force into voltage, force to voltage analogy. So to convert the force into voltage analogy, so I am just from the table what I have shown in the previous slides, the equivalent of force is what? The equivalent of force is equal to what? Voltage. And now the equivalent of velocity v1 is equal to current will be I1, and the equivalent of velocity v2 is equal to what? Current I2. In the same way, what is the equivalent of mass? So m is equal to, the equivalent of mass element m is equal to L, and ikkada L1, and m2 అనేది ఏమైతది? L2. Now next is the equivalent of B. ఇక్కడ 3 ఉన్నాయి. The equivalent of B is R, that is B1 will becomes R1, B2 will becomes R2, and B12 will becomes R12. And similarly, the equivalent of K, here 2 ఉన్నాయి. K1 is equal to 1 by C1, and K2 is equal to 1 by C2. K2 is equal to 1 by C2 is the equivalence. Now here once again, on replacing, then you will get the equation 3 and 4 changes to then the equation 3 and 4 changes to force badlu emma voltage V is equal to what you will get voltage V is equal to L1 into d I1 by dt plus R1 I1 plus R12 into I1 minus I2 plus 1 by C1 into integration of I1 minus I2 dt, equation 5. And now one more equation you will be getting, 0 is equal to L2 d I2 by dt plus R2 I2 plus 1 by C2 into integration of I2 dt plus R12. Now this time it is I2 minus I1 plus 1 by C1 into integration, this time I2 minus I1 into dt. This is your equation 6, 5 and 6. Okay. Now, once if you got equation 5 and 6, now just so here just I am going to draw the my equivalent diagram. So here just I am replacing this then. Ikkada rasthanamma diagram by seeing those equations. How I am going to get the diagram. So let me take another color. Now if you observe this equation, here voltage is V, it clearly shows that this is the applied voltage. Now which is the sum of L into di by dt ante oka voltage across inductor, R1 into I1 ante voltage across resistance, and I into R12 ante voltage once again, and I into 1 by C integration ante voltage. And it means that voltage is equal to voltage plus voltage plus voltage plus voltage drops. 4 drops unnai. And it means that you are having a series circuit with one voltage source, as I am writing with voltage source kabatti, with one voltage source name as V series circuit KVL kabatti. So this will be L1. Next in series with another element R1, tarvata in series with another element. I am writing like this endukante difference undi kabatti this will be common for another loop also, these elements. So this is what R1 2 and this is what C1 ena, sorry, right, K equivalent to C, right, C1. Now the current flowing here is I1. And now coming to this loop, here left hand side is 0. It means that there is no voltage. One element is what, L2 for next loop, and another element is R2, and another element is, I can write like this, R2, and another element is C2, and remaining 2 elements are common, already draw chesnam. ఈ రెండు ఆల్రెడీ డ్రా చేస్తున్నాం. సో దిస్ ఈజ్ L2 R2 and C2, and the current flowing here is I2. So here is the answer. So here if you observe these two equations, these two అంటే మనం ఏం చేయాలి, ఇంతకుముందు మీరు సర్క్యూట్లో ఏం చేస్తున్నారంటే ఇచ్చిన సర్క్యూట్ నుంచి ఈక్వేషన్స్ రాస్తున్నారు. ఇప్పుడు ఈ ప్రాబ్లమ్స్లో ఏం చేయాలా, ఈక్వేషన్స్ నుంచి సర్క్యూట్ డ్రా చేసే కెపాసిటీ ఉండాలి. ఉంటే సింపుల్గా జస్ట్ కేవీఎల్ అమ్మ, ఎన్ని ప్లస్లు ఉంటే అన్ని ఎలిమెంట్స్ సిరీస్గా కనెక్ట్ ఉంటాయి. ఇక్కడ ఎన్ని ప్లస్లు ఉన్నాయి, 1 2 3 4 అంటే 5 ఎలిమెంట్స్ ఉన్నాయి. సో 5 ఎలిమెంట్స్కి 1 2 3 రాస్తున్నాను సెకండ్ లూప్కి. ఇక్కడ డిఫరెన్స్ ఉంది కాబట్టి కామన్ ఉంటాయి కాబట్టి ఇలా రాస్తాను లూప్స్. హియర్ ఈస్ ద ఎండ్ ఆఫ్ ద ఆన్సర్ ఆఫ్ ద ఫస్ట్ థింగ్, దట్ ఈస్ force to voltage. Now in the same way If you're having any doubts, please unmute and talk. Otherwise, I'm just now in the same way, force to current analogy. Force to current analogy. Force to current analogy. So force to current analogy lo, now here your force will be equal to what? The current I. Okay. Now the voltage, sorry, velocity V will be equal to now here the voltage V1, and similarly the velocity V2. The velocity V2 will be equal to voltage V2. Just observe the table. From that table, I am writing all these things. Voltage V2, and now here the index M1 place low. M1 is equivalent to, in case of that force current analogy, your M1 is the equivalent of which element? If you observe your previous table, if you have taken the screenshot, M1 now this time is equal to C1, and now M2 is equal to what? M is equal to C2 kavati, M2 is equal to C2, and now this B is equal to previously B is equal to in case of force to current B is equal to 1 by R, 1 by R. If you observe, let me show you the table. If you observe this table, if you observe this table here, if you observe, in case of force current, it is the spring K is equal to what? The reciprocal of inductance spring B, sorry, damper B is equal to 1 by R. So here, okay, now here in the same way, here I am writing this one. So damper element B is equal to 1 by R1, 1 by R1, and here this is also 1 by and 1 by, and K is equal to L1. You will get this. You consider this one as L1, and this is what? L2. Now on replacing in this equation 3 and 4, then you will be just, I am erasing these basic equations. Let me erase these basic equations. Then you will get equations 7 and 8. Whatever it may be from the table, you need to extract the data. అంటే మెమోరైజ్ చేయాల్సిన అవసరం లేదు, మీకు ఫెమిలియర్ ప్రాబ్లమ్స్ ప్రాక్టీస్ చేస్తే ఆటోమేటిక్గా అర్థమైపోతుంది. సో నౌ హియర్ if you write the equation once again, equation 1 implies what you will get? Force F place lo em ostadamma, current I is equal to M place lo em ostadi C1 into V place lo velocity V place lo em voltage. So C1 is dV1 by dt plus V1 means what? So the voltage velocity and V1 by B and R1 plus ikkada V1 minus V2 by R12 plus integrate 1 by L into integration of velocity means voltage V1 minus V2 into dt. Equation 7. And now one more equation is equation 2 implies on replacing those variables. So 0 is equal to, we will be getting here C2 into dV2 by dt plus V2 by R2 plus 1 by L2 integration of V2 dt plus 2 more elements there, that is V2 minus V1 into R12 plus one more element is there, 1 by L1 into integration of V2 minus V1 dt. This is your equation 8. Now by seeing the 7 and 8, you need to draw the circuit diagram for electrical system. So here I am just removing this free body diagram. Now I am going to draw the electrical circuit diagram for the given things. That will be the end of my problem. Now how I am going to write the equation? Now if you observe here, this is I is equal to C into dV by dt. Once again I. V by R. Once again I. So it means that I is equal to I plus I plus I plus I. 4 I's are there. It just looks like this. I is equal to, suppose current undi I, I is equal to junction lo if I is flowing, then I1, I2, I3, I4 like this. That is KCL. In the same way, if there are two equations, then there will be two junctions. So I can write the junction 1 and junction 2. As usual, in terms of electrical engineering, I am giving the names of voltages I1 and V1 and V2, junction names. So now here the first element here is left hand side I undi kabatti, just here I am writing I expression. What it is the sum of what? C1 into dV1 by dt. It means that directly I can write here as one element capacitance like this. Okay. Now next is one element is there R1, another element is there R1. So I am writing just this. So this is R1 C1. Now one more element is there R12, but the voltage there is what? V1 minus V2, and another also element is there L1. The voltage is V1 minus V2. It means that I can assume that there is a parallel branch of what are resistances and inductance R, and then inductance L, which is like this. So this is R12 and this is what? L1. And now coming to this second equation V2, LH is 0, hence there is no current source. Now there are how many elements are there? C2 plus R2 plus L2 plus R12 by and L1. R12 L1 already undi. These two are already I have written with the loop 1. Then I will be getting three elements here. One is C2 and another one is L2. Another one is L2 and another one is R2. Another one is R2. Here is the end of my answer. Any doubts? Feel free here to ask. So here is the end of this problem. So finally, the conclusion of this particular concept is, here you are going to solve the problem in this way. First step is write the first basic two equations. ఆ తర్వాత in the general, in the previous question paper, what I observed here is, he will be asking either force voltage or force current. రెండు ఒకే ప్రాబ్లం లో అడగలేదు ఇంతవరకు. సో ఏదో ఒకటి అడుగుతారు, కానీ ఈ ప్రాబ్లం లో మొత్తం అన్ని అడిగేటట్టు నేను క్లియర్ ఆఫ్ చేస్తున్నాను మీకు. సో అది అడిగిన తర్వాత దాన్ని బట్టి యూ కన్వర్ట్ దట్ ఈక్వేషన్, ఫస్ట్ టూ ఈక్వేషన్స్ ఇంటూ ఈక్వేషన్ 3 and 4. ఎందుకు 3 and 4 గా కన్వర్ట్ చేస్తున్నా అంటే, డిస్ప్లేస్మెంట్ గా వస్తాయి కాబట్టి, డిస్ప్లేస్మెంట్ ఈజ్ ఈక్వల్ టు చార్జ్. బట్ ఆల్ ఆఫ్ యూ అవేర్ దట్ ద చార్జ్ పైన మనం ఎలక్ట్రికల్ సర్క్యూట్ కన్సిడర్ చేస్తే, వీఆర్ జనరల్లీ వీ విల్ బి హ్యాబిచుయేటెడ్ ఆఫ్ రైటింగ్ ద ఈక్వేషన్ ఇన్ టర్మ్స్ ఆఫ్ వాట్? కరెంట్. కరెంట్ కి మధ్య ఈక్వేషన్స్ రాస్తాం కాబట్టి జస్ట్ ఐఎమ్ కన్వర్టింగ్ ఇంటూ డిస్ప్లేస్మెంట్, ద వెలాసిటీ, ది డిస్ప్లేస్మెంట్ బై వెలాసిటీ v రాసి మీకు ఏం అడిగితే దానికి ఈక్వలెంట్ టర్మ్స్ రీప్లేస్ చేసేసి రైట్ ద ఈక్వేషన్స్, న్యూ ఈక్వేషన్స్. ఈ న్యూ ఈక్వేషన్స్ కి బట్టి యూ రైట్ ద ఈక్వేషన్. సో ఓవరాల్ ఇంకా ఫైనల్ గా డబ్బింగ్ నాకు ఎలక్ట్రికల్ సర్క్యూట్ ఈక్వేషన్స్ రావడం తెలియదంటే, సింపుల్ గా చెప్పాలంటే, సింపుల్ గా హౌ టు రైట్ దట్ మీన్స్, ఒకవేళ వోల్టేజ్ ఉంది, వోల్టేజ్ సోర్స్ అంటే ఆబ్వియస్లీ ఇట్ విల్ బి ఏ సిరీస్ సర్క్యూట్. గుర్తుపెట్టుకోండి, ఎందుకంటే KVL is equal to applied voltage is equal to sum of voltage drops in the series circuits. అండ్ కరెంట్ ఉంది అంటే జంక్షన్ దగ్గర ఎంటర్ అయ్యే కరెంట్ ప్లస్ లివింగ్ కరెంట్. సో ఇక్కడ లివింగ్ కరెంట్ ఈస్ 4 లివింగ్ కరెంట్స్ ఇలా రాసేస్తాను, 4 లివింగ్ కరెంట్స్. సో టోటల్ కరెంట్, ఇన్పుట్ కరెంట్ is I, like this. Here I is equal to this one plus this one plus this one. అంటే ఆల్ ద ఎలిమెంట్స్ విల్ బి ఇన్ ప్యారలల్. కామన్ గా ఉండేవి మధ్యలో రాస్తాం, మిగతా అంతా కామన్. హియర్ ఆల్సో ద సేమ్ థింగ్, ఆల్ ఎలిమెంట్స్ విల్ బి ఇన్ సిరీస్. కామన్ గా ఉండేవి మాత్రం ఈ విధంగా రాస్తాం. ఈ విధంగా కామన్ గా వెళ్తే లూప్ కి కామన్, ఇక్కడ నోట్స్ కి కామన్. ఈ విధంగా యు ఆర్ గోయింగ్ టు రైట్ ద సేమ్ థింగ్. ఓకే, హియర్ ఇస్ ద ఎండ్ ఆఫ్ మై ఫస్ట్ ప్రాబ్లం. సో నెక్స్ట్ ప్రాబ్లం ఫర్ యూ, మీరు చేయాలా ఇప్పుడు? No, please do this problem. I am just noting you the circuit for the second problem. So your second problem is same question. That is a convert from, now in this problem he is asking you convert torque to torque ఇచ్చినాడంటే ఏమి, మెకానికల్ రొటేషనల్ సిస్టమ్, torque to voltage and torque to current is the question. So please try to solve this question. I am just giving you the problem here. J1, K1, J2, K2, and remaining all are grounded. And let here is the input. that is torque T. Let here is theta 1, theta 2, all are grounded here. This is grounded. Now let this is a B1 and let this is a B2. Theta 1, theta 2 here. So mechanical rotational system is not. Please note down this second problem and try to solve. Two questions, two things he has asked you to find out. One is the mechanical rotational system, rotational to voltage source, tarvata voltage to current source. Now if you observe this given problem, please try to solve. How many variables are there here? There are two variables. First step is theta 1. So next is theta 2. And common element is theta 1 ki theta 2 ki madhya common. Ee data extract cheste saripoyi. What are the elements related to theta 1? One is torque, another one is J1, another one is B1. And theta 2, J2, B2 and K2. What about K1? What about K1? K1 is common between theta 1 and theta 2. Please try to write the expressions and then try to draw the things. Now let me write the final diagram for this one. If you solve that problem, you will be getting the answer like this. Any doubts, please unmute and talk. For loop 2, there are three elements. So this is V, R2, L2, C1. Sorry. Loop 1 के R1, L1, R2, L2, C2, I1, I2. And similarly, if you write the expression, try to find the current diagram, then you can able to get like this. So here there are two nodes, V1, and then let me close this line. V1, V2. So the three elements are there. One is current I, obviously, and another element is R1, and another element is C1. R1, C1. And similarly, next common element here is ఇంతకుముందు capacitance, ఇప్పుడు inductance L1, and there are three elements. One is C2, another one is L2, and another one is R2. So if you solve that problem, you will be getting the answer like this. If you are having any doubts, please talk. Here is the end of my mechanical systems. Answer for second problem. Here is the head of my mechanical system. Please note down or else take the screenshot of this one and verify these two circuits what I have given. Now let me take the attendance. If it is over, then I am going for taking the attendance. Okay, take the screenshot of this one, and final conclusion here is take the screenshot. I am just closing this one. So overall, the final conclusion here is, before taking the attendance, let me conclude here all these things. Just give me a minute. I am closing this class. And Monday I got an extra class. We will start the fresh topic in that particular class on Monday. That is, the PS2 sir is not available, so I will be taking that class on Monday. Now here, as a part of this mechanical system, the overall conclusion is, in two ways he will be asking you. One is to determine the transfer function, and another one is he will be asking you to obtain the electrical circuit. So how to find out the transfer function, everything we have discussed in the previous classes. Now in this class, we have discussed how to find out the electrical circuit for the given mechanical system. So for this given type of given mechanical system, as usual, first extract the data related to all the displacements. Maximum number of nodes you will be getting only 2 based upon the data from the previous question papers. Anyhow, two nodes based upon time factor in the examination. So ఈ 2 nodes ki common elements and unknown elements extract చేయాలా. ఆ తర్వాత write the 2 basic equations. So if it is translatory, then force equation. If it is rotational, then write the torque equation. ఆ తర్వాత you have to go for what? Converting those displacement x's or theta's to what? Velocity. How to convert means all of you aware dx by dt will be equal to dx by dt is equal to what? Velocity or angular velocity w. So దీనిలో కన్వర్ట్ చేసిన తర్వాత you can now finally based upon the asked data. Now in this problem here ask torque to voltage. So equation 3 and 4 ki voltage రూపంలో by using that given table you write the voltage equations. So I am just going back to my slides. So voltage equations ఇది mechanical rotational system ki ఇది, and then rotational translatory systems ki all these are the voltage equations. So write those things under voltage equations, and then this is the equations related to force to voltage equation like this. So balance equation, mass equal to L, B is equal to R, and K is equal to 1 by C. Now in the just previous problem, so here also mass is equal to capacitance, and this is 1 by L and this is 1 by R. So like this is by comparing equivalent, and remember all of you that, so here all of you must remember that here ఇక్కడ రిమెంబర్ చేయాల్సిందంటే x is equal to charge and velocity or angular velocity is equal to current. Now ఇక్కడ x is equal to flux and velocity or angular velocity is equal to the voltage. రూపంలో ఈక్వేషన్స్ రాసేసి కంప్లీట్ గా ఎలక్ట్రికల్ సర్క్యూట్ ఫర్ ద గివన్ మెకానికల్ సిస్టమ్ అనేది మనం రాసేస్తే సరిపోతుంది. రీడ్రా చేసేస్తే సరిపోతుంది. సో whole things what I would like to say here is you can do these things in how many steps? So you can do in the 4 steps. So first step is write the force equation. Second step is convert this force equation into velocity, and అప్పుడు 2 more equations వస్తాయి. Then ఆ తర్వాత మీకు voltage source కావాలంటే write the 2 more equations and draw the electrical circuit diagram. ఒకవేళ current source కావాలంటే write the 2 more equations using current analogy and draw the 6. Overall in maximum you will be getting 6 equations. ఒకవేళ both force to voltage and then force to current అడిగితే you will be getting additional 2 equations. So that will be the end of here is the end of. Now here is the end of my topic name as determination of transfer function of what? Mechanical system. So ఈ ఫస్ట్ 3 టాపిక్స్ అనేది అయిపోయినాయి. అవతల 2 టాపిక్స్, టోటల్ 5 టాపిక్స్ క్లియర్ కవర్. ఇన్ ద నెక్స్ట్ వీక్ we will be closing the next topic, same transfer function but by using what? Block diagram reduction technique. Here is the end of my today's class. If you are having any doubts, you please be feel free to ask. Otherwise, what? Yeah, you can unmute and talk. Let me take the attendance. So thank you very much. Here is the end of my class.